Hi everybody! So today's lesson is going to be on the segment addition postulate. So it's kind of a mouthful. Here it is right here in case you don't know what the word postulate looks like. So our first piece that we're going to look at is though we were going to take a ruler and draw a straight line. We're going to have an example of drawing 6 inches, and then we're going to piece different parts of it together to then come up with the concept of the segment addition postulate. So they're given that we have a line segment AB that is 2 inches long, and then another line segment BC that is 1.5 inches long. So if A and B are 2 inches, and then B is being shared by both segments, and it creates another segment BC that's 1.5 inches long, you can probably in your head come up with 2.5 inches left over if we were to create an imaginary point D at the end to figure out how long the rest of this entire segment would be. That's the whole concept of the segment addition postulate. So you're taking segments and essentially breaking it up into other smaller segments and figuring out how long each individual piece is going to be because you know a total amount. So the formal definition says if B is between A and C, then AB plus BC equals AC. And we can also say that in reverse. So if AB plus BC is equal to AC, then B is going to be between A and C. And now I underlined the words between because when we talk about between, we're actually going to mean that the points are all collinear. So you learned what collinear was with Miss Cintron's video a few days ago. Between means collinear, so they're all going to be on the same line, or in this case, all on the same segment. And here's a diagram, so you can see that point B is between points A and C. It doesn't matter where it is exactly. It doesn't have to be exactly in the middle. It could be wherever you want it to be, as long as it's between them. So we're going to use this concept now to solve some algebraic problems. So in all of these diagrams, we're going to be saying that point B is between points A and C on segment AC. So we're going to use all of this given information, and we're going to break this up into multiple parts. We're going to be drawing a diagram. We're going to be writing a geometric equation and an algebraic equation. And we're going to start getting used to justifying our reasons for why we can write certain things. That's going to be very important when we get into geometric proofs later on. And then, of course, we're going to actually solve the problem. So for our very first one, we need to draw something similar to this diagram with points A and C on the end. Point B can go wherever we want it to, and then we just want to label it with this information. So this is what my diagram would look like. And again, B could go anywhere. We don't actually know. This is an easy one that you can just do in your head. But it will get a little bit more challenging as we go. So our geometric equation means we want to use the geometric items that were given. So we're talking about segments in this case. So we're going to actually write AB, we're referring to the segment, plus segment BC is equal to all of AC. So that's going to be our geometric equation. Now, our reason for being able to write this is because of the segment addition postulate. That postulate is what allows me to write it. Now, the algebraic equation is just going to be me replacing the AB with 20, BC with X, and AC with 27. So I'm creating an equation and then solving it. So I solve for x and it equals 7, which I'm sure many of you could just do in your head. But again, it will get a little bit more challenging. And then for the final solution, we want to end up listing how long each individual segment is going to be. So in the end, we knew AB is 20. We figured out that BC, since it's x and x is equal to 7, then BC is the length of 7. And all of AC, they told us, is 27. Okay, so now let's kick it up a notch. Now we've got two expressions that have a variable involved. Still going to draw it the same way with B between A and C, but now it looks a little bit more confusing and you might have a little harder time of solving this one in your head. The geometric equation is going to look exactly the same because it's still with B between A and C, so we're still going to say that AB plus BC equals AC. Our reason is still going to be the segment addition postulate. Nothing is changing about that. But now our algebraic equation is going to look different because I want to replace all of these segments with their values. So I'm going to replace it, and this is the equation I would create. And then, of course, you want to solve it. So you would end up getting x equals 5. So now the last step is to plug it all back in. I want to figure out how long AB is, how long BC is, and how long AC is. Now I know how long AC is in the end because they told me 21, but I still need to plug in my x equals 5 into both of these expressions. So in the end, you should be getting 20 and 1 to get 21 in total. And you can always double check to see that you solve for x correctly, because when you plug it back in, you would get a 20 and a 1, and in the end you should add them together to get 21. Okay, I'm going to skip this one and we're just going to do one more problem together. So here I again am given all of these expressions. I'm going to draw my diagram with B in the middle, or not in the middle, but between A and C. And I want to label it with all of my given information. My geometric equation, you guessed it, AB plus BC equals AC. And the reason has not changed. It is segment addition postulate. Now for my algebraic equation, again, we're just going to replace all of these segments with their values. And in the end, when you solve for x, you should be getting 7. So now we want to plug in, and we want to solve for AB and AC. The only one we know of is BC. So when you plug them back in, you should be getting 6 and 11. And to double check, they do add up to 17. And you're good to go. And sometimes you will have problems where all three of these are expressions with a variable. That's okay. You solve it the exact same way. All right.